Hello everyone, we are covering section 8.6, which is on solving rational equations. First of all, what is a rational equation? Well, the word rational means fractions. Specifically, rational equations are fractions with variables, and equation means that there's an equal sign. So whenever we're solving something, we want to solve for the variables. We need to figure out what variables, when we plug them back in or substitute them back into the equation, will make the left-hand side equal to the right-hand side, is what we're trying to do. So our goal here is to solve rational equations and also to use rational equations to solve word problems. To solve equations with rational expressions, you simplify the equation by clearing the equations of any denominators. The way we're going to do this is to multiply by the LCD, which is the least common denominator of the rational expressions in the equation. So our goal here is to look at our denominators, figure out the least common denominator is. We're going to multiply every piece of the rational equation by that least common denominator. So let's look at example 1. What are the solutions of the equation? If we want to find our LCD here, our least common denominator, we're going to look at the denominators that we have. The left-hand side denominator is x plus 2. The right-hand side denominator is x plus 2. Well, they're both the same, so that means our least common denominator is x plus 2. Since that's our least common denominator, we're going to multiply each piece, and in this case it's both sides, by x plus 2. When we do that in this specific example, you'll notice that the denominator and the x plus 2 that we multiplied by end up canceling out. So what we're left with here is just the numerators. X minus 1 equal to x squared plus 2x minus 3. Another way to think of this specific example, since both the denominators are the same, for these two rational expressions to equal each other, if the denominator is the same, the only way for them to be the same is if their numerator is the same. Now, I showed you the way by multiplying by the LCD because that's how we're going to do all the other problems. But again, for this specific one, since the denominators are the same, the only way for these rational expressions to be the same is that if their numerators are the same as well. So that's why all we end up doing is setting the numerators equal to each other, and now we need to solve. This equation is quadratic, since the highest exponent is a 2. The way we solve quadratic equations is to try and set it equal to 0, and then factor if possible. So let's go ahead and set this equal to 0 here. In order to do that, we are going to subtract x to both sides. So 2x minus x is 1x. And then add 1 to both sides. Negative 3 plus 1 is negative 2. Now that I have this quadratic equal to 0, I'm going to try and factor it. If it doesn't factor, you can always use quadratic formula. This one does factor. It factors to be x plus 2 times x minus 1. Since 2 times negative 1 gives us negative 2, and 2 plus negative 1 gives us the coefficient of 1 in front of x. Using zero product property, I can set both factors equal to 0. So x plus 2 equals 0, and x minus 1 equals 0, and then solve those. Subtract 2 to both sides, we get x is negative 2. Add 1 to both sides, we get x is 1. With these, you want to check and make sure that our solutions, when we substitute them back into the original equation, do not make our denominator 0. Otherwise, it will be undefined. Notice that if we were to substitute negative 2 back into the original equation, we would have a negative 2 plus 2 on the denominator, which makes it 0. So negative 2 is actually not part of our domain, which if you think back to section 1, that would be where we did not include negative 2. We put x not equal to negative 2 as part of our domain. So we're not going to include negative 2 there since it makes the denominator 0. If we substitute 1 back into the original equation, the denominator is 3. That's totally fine. If you want to actually substitute 1 in, you'll see that the left-hand side equals the right-hand side, so that's an actual solution. Let's look at another one. B, x over x plus 1 plus 3 over x plus 4 equals x plus 3 over x plus 4. Our goal again is to find our least common denominator, and then we're going to multiply each part of this equation by that denominator. Our denominators are x plus 1, x plus 4, and x plus 4. So then our least common denominator is going to be x plus 1 times x plus 4. Take one of each piece, multiply them together. So we're going to take that LCD and multiply it by each piece of this rational equation. So I'm going to multiply it by x times x plus 1. I'm going to multiply it by 3 over x plus 4. And I'm going to multiply it by the right-hand side, x plus 3 over x plus 4. Nice things happen here. We can cancel out the x plus 1s on that first part, so all we're left with is x plus 4 times x. On the second part, the x plus 4s cancel, so we have just 3 times x plus 1. And then on the right-hand side, the x plus 4s cancel, so we have x plus 3 times x plus 1. So now I'm going to write out what we have left. On the first part, we had x plus 4 times x, plus, on the second part, we have 3 times x plus 1, equals, and then on the right-hand side, we have x plus 3 times x plus 1 left. Notice what happened here when we multiplied by the LCD, we no longer have denominators, and that was our goal, to get rid of the denominators to make it an easier equation to solve. So it's no longer a rational equation. This is going to be a quadratic equation as well. All right, so let's go ahead and distribute. We can distribute the x. When we do that, we'll have x squared plus 4x. Distribute the 3. When we do that, we get 3x plus 3. And then on the right-hand side, we're going to distribute as well, or you may have learned it as FOIL. When we do that, we get x squared plus 3x plus 1x, so that gives us plus 4x. And then plus 3 times 1, which is 3. So here we have a quadratic equation. Whenever we have a quadratic equation, we want to set it equal to 0 and solve, just like we did in A. This one ends up being nice, though. If we try and set this equal to 0, we would subtract x squared to both sides. But when we do that, we get x squared minus x squared. So the x squareds cancel each other out. They become 0. And then here, if we do the same thing with the constant terms, the 3's, if we subtract 3 to both sides, we get 3 minus 3, which is 0. So those cancel. And then what we have left, we need to collect like terms here. On the left-hand side, 4x plus 3x is 7x. And then on the right-hand side, we have equal to 4x. We're trying to set this equal to 0, so let's subtract 4x to both sides. 7x minus 4x is 3x, and then 4x minus 4x, we get 0 there. Much easier equation to solve for. Divide both sides by 3. 0 divided by 3 is 0. So this is our only possible solution. Make sure to plug it back into the denominators of the original equation. When we do that, we do not end up with 0 on the denominator. So this is an actual solution. Our solution is 0. Let's look at another one. C is 2 over x plus 2 plus x over x minus 2 equals 1. Again, we're thinking of our LCD. That's what we want to multiply each piece by. Our denominators in this case are x plus 2 and x minus 2. So if we multiply x plus 2 and x minus 2 together, that will give us our LCD. We're going to take that LCD and multiply it by each piece. So the 2 over x plus 2, I'm going to multiply by x plus 2 times x minus 2. The x over x minus 2, I'm going to multiply by x plus 2 times x minus 2. And then I'm going to multiply 1 by x plus 2 times x minus 2. When we do this, our denominators will cancel. Notice that the x plus 2's will cancel in the first part. The x minus 2's will cancel in the second part. And then we didn't have a denominator on the right-hand side, so nothing will cancel there. Let's write down what we have left now. So from that first piece, we have x minus 2 times 2. From the second piece, we have plus x times x plus 2. And then we have equals 1 times x plus 2 times x minus 2. The 1's not necessary to write, so I'm just going to write x plus 2 times x minus 2. Let's go ahead and distribute the 2. So we get 2x minus 4. Distribute the x. We get x squared plus 2x. And then distribute the right-hand side. When we do that, we get x squared plus 2x minus 2x, so that's 0. And then 2 times negative 2 is negative 4. We have a quadratic, so we want to try and set it equal to 0 and solve again. When we try and subtract x squared to both sides, x squared minus x squared is 0, so those end up canceling. When we subtract our constant terms, in this case we're going to add 4 to both sides. If I add 4 to both sides, those negative 4's become 0, so those cancel. So what we have left are some like terms. 2x plus 2x gives us 4x, and then we had 0 left on the right-hand side. If we divide by 4, we get that our only possible solution is 0. Now again, if you substitute 0 back into the original equation, our denominators do not become 0. So this is actually a solution. If you substitute 0 into the whole thing, the left-hand side will equal 1, which is the right-hand side. Go ahead and try the got it. Pause and try the got it. Okay, going through the got it's fairly quickly here. If we look at D, our LCD is x minus 2. So you're going to multiply both sides by x minus 2, which cancels out the denominator. So the new equation is just 4 equals x minus 1. Add 1 to both sides, you get x is 5. In part E, our LCD is x plus 2 times 2x plus 3. So you're going to multiply both sides by that LCD. The x plus 2's cancel on the left, and the 2x plus 3's cancel on the right. So what you have left with is 2x plus 3 times 4 equals 5 times x plus 2. Distribute the 4, you get 8x plus 12. On the right-hand side, distribute the 5, you get 5x plus 10. We want to solve for x. So you're going to subtract 5x to both sides. 8x minus 5x is 3x. Subtract 12 to both sides. 10 minus 12 is negative 2. So you have 3x equals negative 2. To solve for x, you need to divide both sides by 3. So you end up with x equals negative 2/3. And in F, our LCD is x plus 1 times x minus 1. So you're going to multiply each piece by that. Notice that the x plus 1's cancel in the first part, the x minus 1's cancel in the second part, and then there's no denominators on the right-hand side, so nothing cancels. What we're left with after the canceling is x minus 1 times 5 plus x times x plus 1 equals 5 times x plus 1 times x minus 1. When we distribute the 5, we get 5x minus 5. Distributing the x, you get x squared plus x. If you distribute x plus 1 times x minus 1, you get x squared minus 1. On the left-hand side, you can collect like terms. 5x plus x gives you 6x. So now on the left-hand side, we have x squared plus 6x minus 5. And on the right-hand side, you can distribute the 5, so you get 5x squared minus 5. This is quadratic, so we're going to set it equal to 0, and then try and solve. Looking at the x squared terms, we can subtract x squared to both sides, you get 4x squared. Subtract 6x over to the other side, so you get minus 6x. And then with our constant terms, if we add 5 to both sides, the negative 5's cancel, they become 0. So all we're left with is 0 equals 4x squared minus 6x. Now we can factor and solve this. There's a GCF here of 2x that we can factor out. That's the only factoring you can do. So if you factor out the 2x, then you're left with 2x minus 3. Since we have 0 equals 2x times 2x minus 3, we can use zero product property. So set each factor equal to 0. 2x equals 0 and 2x minus 3 equals 0. And then now you just solve both of those. So divide by 2, you get x equals 0. Add 3 to both sides, you get 2x equals 3, and divide by 2, you get x equals 3 halves. So here's an example where you have two solutions. The other type of question you'll be asked in this section is to solve each expression for the given variable. So let's look at b. We have h equals 2a over b, and we're trying to solve for b. When it says we want to solve for b, that means we want to get b by itself. Notice that these are rational equations, and just like we did before, we can find the LCD to rewrite it as something that's not a rational equation. It might be a little bit easier to solve for the variable we're trying to solve for. So our LCD here is b. That's the only denominator we have. So I'm going to multiply both sides by that b. When we do that, the denominators cancel on the right-hand side, and I can rewrite this as b times h equals 2a. Remind yourself what you're trying to solve for. We're trying to solve for b. So if I want to isolate b here, right now I'm multiplying b times h. The opposite of multiplication is division. So we want to divide both sides by that h. That way our b is going to be alone or isolated. So when we divide by h, we end up with b equals 2a over h. This is our answer. Remember, we were trying to solve for b. We got b by itself. So our answer is b equals 2a over h. Let's look at another one. We have h over t plus 16t equals v naught. So one way to say this is v naught or v sub 0. And here we're trying to solve for h. So we want to get h by itself. Again, we have a rational expression here. Our LCD is t. That's the only denominator we have. So I'm going to multiply every piece of this rational equation by t. When we do that, the denominator is no longer there. Okay, what we have left is just h plus, now 16t times t is 16t squared equals v naught times t remember, we're trying to solve for h. So if I want to isolate h, get it by itself, right now I'm adding 16t squared to h. So to move that 16t squared to the other side, I want to do the opposite of addition, which is to subtract it to the other side. Okay, so what we're left with is h on the left equals v naught times t minus 16t squared. We isolated h. There's nothing else we can do. So that is our answer. We have one more together. We have m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is our slope equation. Here we want to try and isolate or solve for x sub 1. We have a rational equation here. So let's get rid of the denominator. Our LCD is the only denominator we have, x sub 2 minus x sub 1. So let's multiply each piece by x sub 2 minus x sub 1. Okay, when we do that, notice that our denominators cancel. So what we're left with is, on the left-hand side, x sub 2 minus x sub 1 times m equals, and then on the right-hand side, what we're left with is y sub 2 minus y sub 1, since the x sub 2 minus x sub 1 is canceled. Remember, we're trying to solve for x sub 1. Right now, we have a little bit of a problem because x sub 1 is inside parentheses. To rewrite it without parentheses, we can just simply distribute the m. When we do that, we end up with x sub 2 times m minus x sub 1 times m equals y sub 2 minus y sub 1. We're trying to solve for x sub 1. Right now, we have this x sub 2 times m on the same side as that x sub 1. So let's subtract x sub 2m to the other side. When we do that, we're left with negative x sub 1 times m equals y sub 2 minus y sub 1 minus x sub 2 times m. Again, we're trying to solve for x sub 1. Right now we're multiplying x sub 1 times negative m. The opposite of multiplication is to divide. So let's go ahead and divide both sides by negative m. When we do that, we finally have x sub 1 isolated on the left. And then if I'm dividing by a negative on the right-hand side, another way of thinking of dividing by a negative is just switching the signs on the numerator. So instead of having y sub 2, I'm going to have negative y sub 2. Instead of having negative y sub 1, I'm going to switch the sign and have positive y sub 1. And then instead of having negative x sub 2m, I'm going to switch the sign and have positive x sub 2m. And this was all over m still. Again, we switched the signs because we were dividing by a negative. So there we go. We isolated x sub 1. So our answer is x sub 1 equals negative y sub 2 plus y sub 1 plus x sub 2 times m all over m. Go ahead and pause and try the got it. Okay, going over the got it relatively quickly here. We have a equals x plus y plus z over 3, and we want to solve for x. We have a rational equation here, so we want to multiply by the LCD. The only denominator we have is 3, so that is our LCD. Multiply both sides by 3. When you do that, the denominators cancel on the right-hand side. So what you're left with is 3a equals x plus y plus z. Remember, we're trying to solve for x. Right now we're adding y and z to x on the right-hand side. So the opposite of addition is to subtract. So you can subtract both sides by y and z. When you do that, you end up with 3a minus y minus z equals x. Since x is by itself, that is your answer. That is it for Chapter 8. Go ahead and submit this homework by Friday. I hope you are all doing well still.